Okay, this is Physics 102, Exam 3, the free response. I have a circuit here. It's turned on and allowed to charge the capacitor. And I want to know at what time is the charge on the capacitor 5 microcoulombs. It said coulombs on your test. So I know that the charge for a charging capacitor looks like this. And I want to know when is it equal to 5 microcoulombs. This big Q right here is equal to CV, and so that's going to be 3 microfarads times V, which is 6 volts, times 1 minus e to the minus t over R, which is 2 mega ohms, times C, which is 3 microfarads. And so that gives me let's see, I have 5 over 18 equals 1 minus e to the minus t over 6. And 5 over 18 is, let's see, I 0.722, that's not 5 over 18. That's equal to e to the minus t over 6. So I subtracted 1 from both sides, and then they were both negative, and I got rid of those negatives, so I had a negative and a negative here, and make those positive. And then I take the natural log of both sides. When I take the natural log of both sides, the natural log gets rid of that, and the natural log of 0.722 is negative 0.3254. And that's equal to negative t divided by 6, and I solve that for t, and I get 2.0 seconds. So that's the answer for A. And what is the time constant for this RC circuit? Tau is equal to R times C. That's 2 mega ohms times 3 microfarads. That's equal to 6 seconds. That's what we had up here, remember? How long does it take to fully charge the capacitor? The time to fully charge, I'll call it T charge, is equal to 10 times tau, that's equal to 60 seconds. Sketch a graph of the charge versus time. Okay, charge versus time for this looks like this. You didn't have to do this, but it does max out at Q equals CV. All right, number 2, here I have light traveling through 3 media as shown here. I want to know what is the angle, and then how does the light ray bend? Well, I'm going from a low to a high, and then from a low to a high. So each time I'm going to be bending towards the normal. It might be hard to show, so I want you also to circle the words there. And I want to know what is the angle here. What is that angle? I already know that it should be less than 50 degrees, so let's see what we find it to be. To do that, I say N1 sine theta 1 equals N3 sine theta 3. So that is 1.1 sine of 50 equals 1.5 sine of theta 3. 1.1 sine 50 over 1.5, and then to find theta 3, I take the inverse sine of that quantity, and that's equal to 34 degrees. And then I circle the words there, towards. A proton enters a magnetic field of 0.2 Tesla with a velocity of 3 times 10 to the 6, as shown here. What is the radius of the path? So first of all, our cyclotron equation is R equals mv over qb. So I just need to know the radius. This is easy. I need to know the proton. My mass is 1.67 times 10 to the minus 27 kilograms. My velocity is given. It's 3 million meters per second. And Q is for the proton. That's 1.6 times 10 to the minus 19. That's on your equation sheet. And then B is 0.2 Tesla. And that gives me an R value equal to 0.16 meters. Well, it actually should be 366 there, but oh well. I'll keep 0.16 or whatever, 0.15, whatever it was. And then for B, I want to know the radius of the path that the proton follows. Well, I know my velocity vector is there, my force vector is there. So if I have a velocity in that direction and a force in that direction, what is that? Out of the page. So my magnetic field vector is out of the page. So you could just draw it like that. You could say in the plus C, or you could say out of page. Okay, let me just show you. So these dots up here, these are actually just for my bookkeeping. But if you got them all right, then you'll have marks in A. If you got them just half right, you get a mark in B and no mark in A. So it would look like, oops, well, sorry, I got rid of that. But anyway, it would, there we go. If you have a mark in B, that means you just got it half right. And if you have no mark at all, that means you didn't get any credit for that question. All right, let's look at the multiple choice part now. First, it's your version number. There were 3 different versions. Which of these statements about a household circuit is true? The household circuit is connected directly to the earth. That is true by the ground. Remember that copper wire that goes down into the ground. The transformer changes the electric current from DC to AC. No. The transformer steps down or steps up the voltage, but it doesn't change the type of current that you have, at least not the transformer that you have outside your house. I'll probably clarify that. So the transformer outside your house. And then the circuit breaker protects the user from faulty devices. Nope, that's the GFI does that, or GFCI. And a ground fault circuit or interrupt turns off if IN is greater than I out for any particular device. That is true. If your I out is small, that means you're losing current somewhere. So 1 and 4 are correct for number 2. Number 3, you have a circuit breaker is rated for 15 amps. All the devices operate at 120 volts. Which ones can operate on the circuit? So I have this collection of devices. This carries 10 amps, 1 amp, 5 amps, 5 amps, and 4 amps. And so here I have a toaster, blender, and TV. That's 10 plus 4 plus 5. That's 19 amps. Nope, that's not going to work because it's over 15. Here I have the refrigerator, blender, TV, and radio. That's 5 plus 4 is 9. Plus 5 is 14. Plus 1, that's 15. That should be my answer. But let's just check these others. Toaster, TV, and radio. 10 plus 5 plus 1 is 16. Oh, that's going to kick the circuit off. And then refrigerator, blender, and toaster. 5 plus 4 is 9 plus 10 is 19 amps. So yeah, B is the right answer for number 3. I have an RC circuit. There's the resistance, capacitance, and the voltage of the battery is fully charged by that battery, and then the battery is removed, and the capacitor is allowed to discharge through the resistor. I want to find the charge at a time of 10 seconds after the capacitor begins discharging. So a lot like what we did before in the free response, but now I'm discharging this capacitor. I just want to know the charge. Big Q is C times V. That's 2.5 times 12. That's equal to 30 microcoulombs. I multiplied these two numbers to get that, times e to the minus 10 divided by r times c, that's divided by 5, and that's e to the minus 2, and so that's equal to 4.1 microcoulombs. B is the right answer. Wire has a current of 5 amps in the direction that makes an angle of 15 degrees. Magnetic field. What is the magnetic force on a 2.5 meter length of wire? So F is equal to I LB sine theta. That's going to be 5 amps times L, which is 2.5 meters, times B, which is 3 Tesla, 3.0 Tesla. And then sine of 15. And so my force there is equal to 9.7 newtons for number 5. Looking at number 6. How far from a straight wire is the magnetic field strength? 0.02 Tesla. So I'm looking at a long straight wire, so that's mu naught I over 2 pi r. And I'm looking for how far. That's going to be r. So r is equal to mu naught I over 2 pi b. 4 pi times 10 to the minus 7. I is 0.5 amps divided by 2 pi, and then B must be 0.02 Tesla. The pi's cancel, and then that gives me, for number 6, 5 times 10 to the minus 6 meters. R5 microns. I think this one's OpenStax. I think I actually didn't change the numbers on it either. To create a 0.02 magnetic field, Tesla magnetic field inside a cylinder with a radius of 0.5 meters. So this is a solenoid, and the radius of this thing is 0.5 meters. How many times should you wrap the wire in the cylinder? And then there's the current. So magnetic field is equal to N mu naught I over 2R. And I'm looking for N. So N is equal to B 2R over mu naught I, 0.02 Tesla. 2. The radius is 0.5 meters. 4 pi times 10 to the minus 7 times I, 1.5 amps. All right, and so number gives me 11,000 turns. So I have 11,000 turns of wire. Toward which magnetic pole of Earth is the north pole of a compass needle attracted? The north pole of a compass needle is attracted to the southern magnetic pole, but this is located at the geographic north pole. So the north pole of the compass points to the north, but that's actually the southern magnetic pole. For a magnet, a domain refers to the region within the magnet in which the magnetic poles of individual atoms are aligned. Here I have a positive charge approaching a wire with a current of 1 amp. It's deflected to the left. What is the direction of the current? Okay, so I have a velocity in this direction and a force in this direction. It is a positive charge, and that gives me a magnetic field that is into the page. So I have a magnetic field into the page over here, out of the page over there. What does that give me? Let's be to the right. So use your right-hand rule. B for number 10. This figure shows the path of the charged particle. What is the charge of the particle? Well, my velocity is in this direction, and my magnetic field is out of the page. That should give me a force that is down, but hey, look, I have a force that's up, so it must be a negative particle, so 11 is A. What is the direction of the force on this wire? It's going to be to the left. Fingers in the direction of the current. Fingers fold towards the magnetic field. Your thumb points to the left for number 12. Positive particle is in a B field of a mass spectrometer, moving with a speed of 4 meters per second with 8 Tesla and a radius of 0.5 meters. What is this particular particle? And of course, these numbers are not real. Right? You would have that's a pretty big magnetic field. That's a slow speed. The radius is reasonable. The radius in some of these things are centimeters, although you can make it as big or small as you want. So my cyclotron equation, mv over qb. I'm looking for the mass to charge ratio. So m over q is equal to rb over v. R is 0.5 times 8 divided by V, which is 4. So it's going to be a mass charge ratio of 1, which is yttrium. And I know that because 1 divided by 1 is 1, whereas these others have a mass charge ratio of 2, 4, and 16. You increase the magnetic field in a mass spectrometer, what happens to the path of the particle? Well, look, if I increase B, R goes down. That means it's going to move in a smaller circular path. It'll go from going like this to going like this with a smaller radius. Which of these statements is true? X-rays have a longer wavelength? Nope, they have a shorter wavelength than UV, right? Light. Huygens believed light was a wave because of refraction. Light has a dual nature and can behave either as a wave or a particle. That is true. And prisms separate white light not because they're triangular, though they are triangular often, but because of the dependence of the index of refraction on wavelength. So 3 only. A is the right answer. These two mirrors are an angle of 130 30 degrees to one another. Let me pause while I fix that. Okay, so the 130 degrees to one another, an array of light is incident at 60 degrees. Oh goodness, I'm sorry. So the figure's right, and the text will be right on your test. So if that's 60, that means this is 60. That means this angle is 30 degrees. And if that angle is 30 degrees, that means that this angle is 180 minus 130 plus 30, or that's 20 degrees. And if that's 20, that means this is 70, and this is 70. So the answer is D. Consider the light ray as it travels through the two media. Which of these statements is true? Well, what happens to the light? Well, it slows down here and speeds up, so it turns around, so it goes like that. So it's traveling faster in medium 2. It also has a, I'm sorry, no, not traveling faster. It actually slows down in medium 2, so it's traveling slower in medium 2 or faster in medium 1. So it light's traveling faster in medium 1. This has a low index. This has a high index of refraction because it's kind of like the muddy field, right? Light traveling through air strikes the surface of an unknown liquid at an angle of 60 degrees. So I have air with an index of 1. 60 degrees. If the angle of refraction is 40 degrees, then what is this n? Well, I know it can't be this or that because index just isn't less than 1. To solve this, I say 1 sine of 60 equals n sine of 40. I solve that for n. And I find that it's 1.35. All right, so C. 0 has an index of refraction of 1.33, then what's the speed of light? C divided by n. And that's equal to, I think it's D. Yeah, D, 2.26. An array of light travels from liquid to glass. The refraction is liquid is 1.75. Liquid to glass, 1.75, 1.52. What is the critical angle at the liquid-glass interface? So first of all, I'm moving from a high to a low, so I can get total internal reflection, but I want it to be such that this angle is equal to 90 degrees, and this will be my critical angle, so I'd say 1.75 sine of theta c is equal to 1.52 times sine of 90, which of course is 1. And if I solve that, I get theta c. It's the inverse sine of 1.52 over 1.75, and that is equal to 60.3 degrees. All right, that's the end.